workbook before the homework, you must also have the work up to date before the homework, right? So we need to substitute x equal to 5 over 7, right? So if I put x equal to 5 over 7 here, I'm gonna get, well, let me use a different color. Right? If I put x equal to 5 over 7, 5 times 4 gives me 20. So 20 over 7 minus 3. What's 20 over 7 minus 3? 20 over 7 minus 3 is what? It's negative. That's the first term. So the second term is going to be 5 over 7. The third term, 2 times 5 gives me 10. 10 over 7 minus 5 is what? What? Minus 75. 25 over 7. Can you try to speak up a little bit? Don't be scared of me. Or scared of them now. I'm not scared. Alright. So this is a geometric sequence. Right? So if I wanna find its general term, I need to know what is its common ratio. So I'll say R is equal to T2 over T1. So that will be 5 over 7 divided by minus 1 over 7. And this is the same as 5 over 7 times minus 7 over 1. So the answer will be negative 5. Okay? I hope you got that if you did the question. So the common ratio is negative what? Negative 5. Now, we can prove that that's correct or not. If I multiply 5 over 7 by minus 5, I'll get minus what? 25 over 7. So the common ratio is negative 5. Right? Then my first term is minus 1 over 7. Now I can find the general term because I know the common ratio, I know the first term. So you write the formula Tn equal to A times R to the power of n minus 1. Then allow me to substitute there. And then we keep going down. So the first term is minus 1 over 7. The common ratio is negative 5 or raised to the power of n minus 1. Right, now this one here, I don't encourage you to simplify it further. Okay, so you can stop there. Right? So you can stop there. So your solution will be that. That will be your general term for the second sequence, which is also geometric. Right? Now, after finding these two general terms, we now need to find the 10th term for both of them. Now, before I carry on, is there anybody who has got any questions? Okay, if you don't have a question, then let's carry on. All right, so let's move on to 2.3. Now, we are going to start with the first general term, this one here. Tn equal to 3 to the power of n plus 1. So I'll write here, Tn equal to 3 to the power of n plus 1. Right? So T10 is going to be 3 to the power of minus 10 plus 1. And this will give you 3 to the power of minus 9. All right. Now, if you want to try and simplify this, you're going to end up with a very large number. So you can leave your answer like this. Okay, in exponential form. But if you decide, is it plus 1 or 3? Oh, so it's plus 3. Okay, let me change that. It's plus 3. You were all quiet. It's plus 3. I just sense that something is not right. So let's change that. Yeah, you're supposed to tell me, say, you put plus 1 instead of plus 3. Okay, so that will be 3 to the power of minus 7. Alright, you can simplify that if you want, but it's not necessary. Then, so that's for the first one. The second one is Tn equal to minus 1 over 7 minus 1 over 7 times minus 5 to the power of n minus 1. So we want T10, the 10th term. So that will be minus 1 over 7 times minus 5. We put 10 there. Okay. Now, substitution is very, very important because in most cases, you get a mark for substitution. So don't just rush to move from here straight away, right? Minus 5 to the power of 9. You might lose a mark for substitution. Okay? So our T10 will be equal to minus 1 over 7 times minus 5 to the power of 9. Can you simplify that with your calculators quickly? And tell me the answer. What will be the answer? Are you aware that you're supposed to do this question? Yes. Okay, how many digits are those? Huh? 7. Okay, so what's the numerator? All right. There is no need to convert it to a decimal. Okay. In actual fact, I want to encourage you to convert it to a decimal because of this. Because we have a first term. Our first term there has a denominator of 7. Okay. So that should be a clue to you that it's not necessary to convert that to a decimal. Okay. Otherwise, we have to convert minus 1 over 7 to a decimal as well. And we can end up exaggerating the value of a by converting it to a decimal. So you leave it like that. Okay. All right. Let's come to today's work. Let's come to today's